question is, let A and B be two events in a probability space with P of A is equal to 0.3, comma P of B is equal to 0.5 and P of A intersection B is equal to 0.1. Which of the following statements is or true? 4 statements ABCD given. This question is from engineering mathematics from the topic probability and statistics, subtopic basics and independent events. This is one more question. The solution is so P of A intersection B is given 0.1 and P of A into P of B 0.3 into 0.5. This simplifies to 0.15. So which implies P of A intersection B is not equal to P of A into P of B. Therefore, A and B are not independent. Are not independent events. So that is statement A is not true. Next, P of A union B. Using addition theorem of probability, this is P of A plus P of B minus P of A intersection B. So 0.3 plus 0.5 minus 0.1. This simplifies to 0.7. So P of A union B is equal to 0.7 is true. Statement B is true. Next, P of A intersection B complement. We know that P of A intersection B complement is equal to P of A minus P of A intersection B. That is P of only A. So this is equal to P of A is 0.3. P of A intersection B 0.1 simplifies to 0.2. So P of A intersection B complement 0.2, that statement C is also true. Next, P of A complement intersection B complement. This can be written as P of A union B whole complement using De Morgan's laws. Is equal to, using complement definition, 1 minus P of A union B, since P of A complement is equal to 1 minus P of A. So 1 minus 0.7 is equal to 0.3. So, but given probability of A complement intersection B complement 0.4, so statement D is not true. So statement B and statement C are only true. This one. So the answer is B and C. This is the end of this question. Let A be any n cross m matrix where m greater than n. Which of the following statements is or true about the system of linear equations Ax equal to 0? Ax equal to O. A. Statement A. There exist at least m minus n linearly independent solutions to this system. B. There exist m minus n linearly independent vectors such that every solution is a linear combination of these vectors. C. There exists a non-zero solution in which at least m minus n variables are 0. D. There exists a solution in which at least n variables are non-zero. This question is from engineering mathematics from the topic linear algebra, subtopic system of linear equations and independent dependent solutions, which is 2 marks question. The solution is A is given any n cross m matrix. where m greater than n, that is n less than m, and Ax equal to O be homogeneous system of linear equations. That means n equations in m unknowns. Number of unknowns is m. Since n less than m, n cross m matrix means here n equations in m unknowns. Okay, so number of equations less than number of unknowns, which implies number of equations less than number of unknowns. Therefore, there exist at least m minus n linearly independent solutions to this system. Actually, whenever rank of the matrix is equal to R, then m minus R is the number of linear independent solutions. That's why there exist at least m minus n linear independent solutions. M is number of equations, n is number of variables. So here number of n is number of equations, m is number of variables. Okay, m greater than n means number of unknowns greater than number of equations. Okay, and there exist a solution in which at least n variables, that is n unknowns, are non-zero. Also, there exist m minus n linearly independent vectors such that every solution is a linear combination of these m minus n vectors Okay. Now, statement A is true. Statement B is true. Statement C is also true. Okay. Statement D is true. Statement A, statement B, statement D are true. Okay. So the answer is A, B, D. This is end of the solution. The question is, a bag contains 10 red balls and 15 blue balls. 2 balls are drawn randomly without replacement. Given that the first ball drawn is red, the probability that both the balls drawn are red is. This question is from engineering mathematics from the topic probability and statistics, subtopic dependent events conditional probability, which is 2 marks question. The solution is, so drawn without replacement, first of all, that is dependent events, conditional probability. One by one, drawing without replacement. So every time the total number of balls before drawing a ball reduced by 1. The total number of balls reduced by 1 before drawing the ball. Okay. Solution. Total balls 10 plus 15, 25. 10 red, 15 blue. B stands for blue, R stands for red. Given that the first ball drawn is red. Now the question requires both the balls both the balls drawn are red. So that means we are going to find the probability of second ball drawn is red. Okay. Therefore, the remaining balls in the bag is 24, for which there are 9 red balls. So from these 24, a ball can be drawn, a red ball can be drawn in 9 by 24 ways. Therefore, the probability that the second ball drawn is red. That means in the second draw we are drawing one ball only. There are 24 balls left after first ball drawn. So first ball drawn. So keep that first ball outside. Now the bag containing remaining balls 24, for which 9 red balls. So the second ball drawing a second ball means we are drawing one ball from the 24 balls. Which ball we are drawing? That is red, because the question requires both the balls drawn are red. So is 9C1. There are 9 red balls. One red ball can be drawn in 9C1 ways. Total balls 24. One ball can be drawn in 24C1 ways. So probability of that the second ball drawn red is 9C1 by 24C1. So this is equal to 9 by 24 is equal to 3 by 8 is equal to 0.375. Therefore, the probability that both balls drawn are red is 0.375. So the answer is 0.375. This is end of the question. The question is, when 6 unbiased dice are rolled simultaneously, the probability of getting all distinct numbers, that is 1, 2, 3, 4, 5 and 6 is 4 options A, B, C, D given. This question is from engineering mathematics, from the topic probability and statistics, subtopic basics, which is 1 mark question. The solution is so total number of outcomes, that is n of s. 6 dice are rolled in 6 power 6 ways. Okay. So when 6 dice are rolled, the total number of outcomes is 6 power 1, 6 power 6. When a die is rolled one time, the total number of outcomes is 6 power 1. When a die is rolled in 2 times, or 2 dice rolled one time, that the total number of outcomes is 6 square. Like that, 6 unbiased dice rolled simultaneously, then the total number of outcomes is 6 power 6. Total possible outcomes. That is total possible outcomes. Let A be the event of getting all distinct numbers because the question requires all distinct numbers. That is, all the 6 faces are distinct. Then n of A is 6 factorial. That means 6 numbers 1, 2, 3, 6 can be arranged in the 6 places is 6 factorial ways. Okay. Without repetition. Distinct numbers. 6 numbers 1, 2, 3, 4, 5, 6 can be arranged in 6 places without repetition. That is 6 factorial ways. Therefore, required probability is P of A is equal to 6 factorial by 6 power 6. So the 6 factorial is continuous product of 6 natural numbers. This is 6 into 6 times multiplying. So this simplifies to 1 6 cancelled, 3 into 2 1 6 cancelled, and remaining 4 and 5. 4 is cancelled with 2 6s 2 times. So 3 into 3 6 into 6. Numerator 5 left. After simplifying, denominator 4 into 4 6 into 6. 36 into 3 into 3 9. 36 9s are 324. So the answer is 5 by 324. Accordingly, the option is B. This is the end of the question. The question is, let A be an n cross n matrix over the set of all real numbers R. Let B be a matrix obtained from A by swapping 2 rows. Which of the following statements is R true? A. The determinant of B is the negative of the determinant of A. B. If A is invertible, then B is also invertible. C. If A is symmetric, then B is also symmetric. D. If the trace of the A is 0, then the trace of B is also 0. This question is from engineering mathematics, from the topic linear algebra, subtopic basics. This is 2 marks question. The solution is Swapping two rows means interchanging two rows. So let us consider a 2 by 2 matrix, square matrix. 1, 2, 2, minus 1. Then B is equal to swapping two rows means interchanging R1 and R2. You will be getting B matrix 2 minus 1, 1, 2. Apply R1 interchanges R2 on A. Now, so first see, determinant of B is the negative of the determinant of A. Let B. Two by two matrix A, B, C, D determinant is AD minus BC. 2 into 2, 4. Minus of minus 1, 4 plus 1, 5. And det A. 1 into minus 1 minus 2 into 2, 4 minus 5. Okay. So therefore, determinant of B is the negative of the determinant of A. Determinant DET means determinant of B is the negative of the determinant of A. That is A statement A is true. Next. If det A not equal to 0, then det B, that is A transpose, interchanging of two rows will be affected by minus sign only. So det B is also, then det B is also not equal to 0. So that means, therefore, when determinant not equal to 0, then only that matrix has inverse. That is, the matrix is said to be invertible. If A is invertible, then B is also invertible. Next. A is symmetric and B is not symmetric. See, first row equal to first column elements, second row elements equal to second column elements. A is symmetric. Look at the B. First row elements is not equal to correspondingly first column elements. Okay. A is symmetric, but B is not symmetric. B is not symmetric. Now, trace of A. Trace A. Trace of the square matrix is sum of the diagonal elements 1, minus 1, 0. Trace B. Two plus 2, 4. So, trace B not equal to 0. Trace A is 0. So, only the first two statements are true. Accordingly, statement A, statement B are true. This is the end of the solution.